All right, so we're gonna apply the laws of the trig laws to word problems. Okay. Now that we've learned how to solve for sides and angles using sine cosine, we can start solving for word problems. So some definitions before I start. Do you remember your angle of elevation, angle of depression? I'm not sure if you remember that, but I'm just gonna say this. If this is a person, there's always a horizontal line that you need to take into account. Where's my ruler? There it is. Okay, you need a horizontal line. You always, when it comes to angle of elevation and depression, you always measure them with respect to a horizontal. Don't forget that. Not a vertical, a horizontal. Okay, so if you were to see a bird up here, right, or a tower or a building, you're tilting your head up, okay? That angle that starts from the horizontal all the way to the line of sight is called the angle of elevation. There'll be a number there. So it has to look like that. If you're looking on the ground and there's a spider there, okay, you look down. Obviously now, with respect to the horizontal, you're tilting down. That is your angle of depression. Okay, so remember that. So if you're a pilot flying a plane or something and you're looking down to the ground or the airport, there's a horizontal up there at the airplane, and then from there you go down, right? That's your angle of depression. Supplementary angles, I think we all remember those. Add up to 180, so I'm going to keep this very short here. So basically, if you see anything like that, if this is 30, then we know this is 150, right? So you got to keep that in mind. Sometimes it happens like this, okay? Where if this is a 20 here, then we know immediately that this is 160. Very, very helpful. It helps us a lot when we're stuck, okay? Complementary angles add up to, any guesses? 90. It's right to complement someone, okay? It's the right thing to do. So there you have your 90s, okay? So if you see a 90 at all, and it's split up like this. If this is 30, then this will be 60, of course. A lot of times the 90 happens like this. Somebody's at the top of a cliff and looking down at, let's say, a boat down here. It's supposed to be a boat. Where would the angle of depression, if I said angle of depression of 30 degrees, where would you put it? Here or here? Here, right? Okay. Good answer. Angle of depression. A lot of students want to put it here because, hey, it's like going down here somehow. No, it's like there's a horizontal. Okay, horizontal and the line of sight going down. So you measure 30 from the horizontal down. Okay. Anyways, if this is 30, what do we know about this one? 60. There we go. So yes, it does help us to figure out other angles. Guy wires. Anybody know what a guy wire is? You did trig in grade 10, right? You never came across guy wires? Those are wires that support a pole. So the hydro poles out there that you see when you walk around, they sometimes have a wire that supports it, that's anchored to the ground. You know what I'm talking about? It has a yellow sleeve so you don't like hurt yourself. That is a guy wire. Okay, a wire that supports a structure. So if this is your hydro pole here, look at that, eh? Artistic skills come to light here. This is a guy wire. And obviously you can see how trig is going to come into play there because a triangle is formed, right? There's the ground. What would this angle be called out of the two we just learned? Elevation. This is angle of elevation. Yes. Yeah. And I know it's going to come up. It comes up every year. You know what a grandfather clock is? You do? I used to have sleepovers at my grandparents, and it's very annoying because it goes on every hour. It'll make like loud noises for the amount of hours that have gone by. So if it's close to midnight, it makes a noise 12 times, right? So it's one of these that have a little, I don't know what, pendulum, and it just swings back and forth. So this is a grandfather clock. So if that comes up, you can see where the triangle is gonna show up, all right? What kind of a triangle would I have? Isosceles, there you go, you're smart, you're smart. Anyways, I'm not gonna do Pythagorean theorem right now. To be honest, you don't need the Pythagorean theorem to be okay in this unit, so I'll come back to it later. I don't wanna spend too much time on that right now. 36. I will hold off on explaining these diagrams right now because it's going to be too much. You're going to be like, what? Right? What's going on here? So just listen for now. Okay, I'm going to try to come back to these and just explain to you, hey, look at that word problem we just read. This is what you can expect happening. Just so you know, if this is the top of the ocean here, okay, ocean, and this is the bottom of the ocean, okay, bottom. What do we know about this line and that line from the previous unit? They're parallel, yes. Okay, so what would we call this angle right here and the angle right here? Alternate interior. Okay, so see how that's why I do that unit first. What about the other side? Same thing, right? That's going to come in here. So there it is. This is 45, sorry, 45. And same, I use alternate interior angles property, knowing that they're parallel. Okay. What would 30, so from this is like a big ship up here, maybe looking down with some sonar or whatever. What would we call this 30 from up here? Like what angle is the 30? If we angle of depression, that's right. If you can fit this in here, I would love for you to make sure you understand. That's an angle of depression. And so is this one, right? Okay, so from the same point, we're looking maybe backwards, and we're looking forwards, and there's two angles of depressions there, and we could bring them in like that using alternate interior. What would this be right here? This would be the depth of the ocean, right, in that particular spot, which we know as the height of the triangle, right? So this is the depth, which is the height of the triangle. So I don't know if you see everything we're learning is just going to come and jive. It's going to come together here. Do you see two right triangles? I hope you do. Not a problem at all for us. So as you can tell, the trickiest part is going to be interpreting this, like coming up with this diagram. But I will teach you how to do that. You just got to stay with me, okay? There's one more thing. Do you see a supplementary angle? If I'm going back to here, this is a straight line, correct? So if I consider this whole thing as 180, could I just subtract the 30 and the 45 and then get what's left over here? I think everybody would agree that that's the case. So tons of stuff that we can fill in here without doing any sine or cosine law. We just fill it in with info, and then we try solving it. Okay, and if it's a little overwhelming for you, please don't worry about it just yet. We'll do tons of these. What about this one, an airplane here? What's going on here? There are two angles of depressions, right? There's the 30 here, because you got to go from the horizontal down. There's the 30, and then there's the 45 going down here. Okay, two angles of depressions, right? Are there still parallel lines here? Absolutely. This one is parallel to this one. And I would like to use two different colors for this one. This 45 here, if you come down this transversal, that 45 will come over here, correct? I know it's a little weird. This is such a big arc and this is a small arc, but don't worry about that. Just remember, horizontal touches this transversal. So I have another 45 here. And let's use a different color for the 30. This 30 here, right? If you come down this transversal, because it's touching this, we have a 30 here, correct? I use alternate interior, okay? Alternate. I'm just going to go AI here. That's the way the world is going anyway, so might as well. AI, that's how I got those. From the angle depressions, I brought them down here and here. Let's use a different color if you have. Sorry, I know you're probably scrambling to get. What about this one here, this angle right here? What would I use to figure out this one? 180? Yeah, let's just call it the 180, the supplementary, the straight angle. I don't care how you come up with it, but this one is a supplementary angles. So I'm just going to go 180 minus 45, and then I end up with 135, correct? You're with me, right? I know it's a Monday. So do you see how just knowing about angles will fill this up in no time? Okay, it'll fill it up in no time, and then next thing you know, you can solve everything. You've got the height of the triangle flying above ground here, so we'll deal with that. But I think that doing this before we jump in is going to help us. Can we find this one here? This little wedge? 45 minus 30, right? That's 15 here. This little wedge is 15. And if you miss that, you could go sum of triangle. 180 minus 135 minus 30 would also give you this little wedge here. Okay, so there's a lot of ways to get to the answer. All right, let's go to 37. These ones are probably questions up here. These are dealing with angle of elevation because you've got your ground, right? The horizontal ground and the line of sight going up. So let's say you have a hot air balloon and you've got your angle of elevation here. A person is maybe standing here. Another person is standing there. They're both looking up at the hot air balloon. By the way, without solving, which one of these people is closer to the hot air balloon? 35 or 43? Okay, the closer you get to something, the higher you have to look, right? So it is actually this person right here is closer because they have to tilt their head a little higher. Okay, so that's a little bit of a hint sometimes. It helps you out. Even though it doesn't really matter, I'm not going to ask you to draw it to scale. I just want you to remember that. Okay, so we could figure out how high above the ground is the hot air balloon. Remember, we learned about finding heights today? So we could easily do that. There's a slant here. We've got the angle there. We could find the height. So everything I've been teaching you is to prepare you for this. Okay. In this case here, we don't know how far apart these two individuals are. in this example right here, they tell us how far apart they are. Okay, so every question will be slightly different, but this is kind of how it's going to come together. Okay. Let's do these are the trickier ones. And you should have seen these in the intro, but you use SOHCAHTOA. We don't use SOHCAHTOA anymore. Let me explain this scenario. Let's say you're a person looking up at like a tall building, let's say the Toronto CN Tower. Okay, so you're here, you look up, and then you move closer 35 yards, you look up again, right? So that's a scenario here. They might ask you, how tall is the tower, right? So you technically have everything you need to get started. How so, Mr. Dirksen? I don't know. Like, look at this triangle. Can you figure out this angle right here? It's 150, right? Once you've got these two, you can figure out this one. And then you have what? You have a pair, right? Don't ask us questions we don't know the answer to. I don't know what you're trying to say here. Yeah, but we have a pair, and all of a sudden sine law comes into place. You can use sine law to solve, okay? So what about this one right here, that one right next to it? This is where the individual stays put, but they may look at the bottom of a sign and then look up, right? Tilt their head up, and so now we're trying to find like maybe how tall is the sign that we're looking at, or whatever you're looking at, right? Maybe there's a plane here and another plane flying above it. How much higher is that second plane, right? So we can do that as well. So let's dive into an example. So if this is a little overwhelming, I just wanted to at least get you to see different scenarios, and I might come back to those later to help you out, okay? So, solving word problems. This is the first one, okay? A radio antenna is supported by two wires on opposite sides. Those are guy wires, by the way. The wires are anchored 60 meters apart, so that is important. We know that they're 60 meters apart on the ground, because anchored means they're like permanently attached to the ground at that point. One wire has an angle of elevation of 62 degrees, while the other one has an angle of elevation of 75 degrees. So the word angle of elevation should mean something to you. It's asking us to sketch, determine the length of each wire, and then calculate how far up the pole the wires are attached. Let's do one thing at a time. A first. I'm going to ask you to sketch quite often. So let's say this is the antenna here. Okay, and we've got. By the way, it doesn't necessarily mean that it's going to the top. It just means that, right, the wire is anchored here, and another wire is anchored on the other side. Do not assume that they're the same distance away from the antenna. Okay. Tower, antenna, doesn't matter. So we've got the 62 and the 75. And both of them, it makes sense that they're angle of elevation because it's starting from the ground, which is our horizontal here. And they're 60 meters apart, so 60 meters goes from end to end, okay? Please don't split this in half and say this is 30 and that's 30. Most of the time that's not going to work for you, okay? So don't be tempted to do that, okay? This will make a 90 because any antenna hopefully makes a 90 with the ground. So you can rest assured that that will be the case. Let's solve now. Determine the length of each wire. Let's call this wire 1, and this will be wire 2. Put letters in there if you don't have any. X, Y, A, B, whatever letters you want to use, please use them. Okay. How would we do this? Let me tell you, ignore the height for now. You see this angle here? Right? If we can somehow get that, we have a pair. And we can easily do that because we've got two angles, right? So what should I call this angle right here? I'm going to call this angle A for antenna. Okay. So 180 minus 62 minus 75. So you're going to have to become creative with assigning letters. And so we have, there's my antenna, and that is 43 degrees. That's usually worth a mark. Okay, so if the question is worth more than 2 marks, then you know that you probably have to find an extra angle. So now you have a pair. Let's write that in here. 43, I'm writing it over top of the antenna so you understand it's the whole thing up there. So we go sine of 43 over 60 meters. And now you have to be careful. If you want to solve for wire 1, you got to use angle the 75, right? So if you're going to say sine of 75, then it's W1 that you're trying to find. And you go 60 times sine of 75 divided by sine of 43. And that gives you 77.68. And we are in meters. Don't forget your meters. Don't forget your units. It's going to be a little tight, but I'm going to try to fit. We have lots of room, so we'll just do the next one here. I'm going to use the same pair I already have, but now I'm going to use 62 to find W2, right? So sine of 62. So we're trying to solve for a side length. Could you use SAS, right? You already know W1, angle, and the 60. Absolutely. If you want to use cosine law, go for it. Yeah. Sine of 43. W2 is 84.98. So now you have both wires, so we're good to go. C. C is asking, if you look up here real quick, how high up the antenna are the wires attached? That would be the height of our triangle, correct? In this case. Asking for height of triangle. So how would we do this? This is where you go to your study sheet and you're like, W1 times sine of 62, correct? W1 I already know, 77.68. And that is 7503. So that's not necessarily the height of the tower, it's just how high up the tower are these wires attached to. Okay? They are attached at a height of 75.03 meters above ground. Yeah, it'd be fine. If you just circle, I need you to circle, clearly indicate your final answers. Okay. All right. So what I'm going to ask you to do, obviously make sure you have your study sheets updated with a height and whatnot. Yes? You got a different answer for W2?
No, I got 77.
I switched it. Can we, easy fix, right? So you're telling me, oh man, 75. Sure. 1 sec. 1 second, YouTube world. I'm just showing my students that I'm human. Oh yeah. So this is 84.98. Thank you. Appreciate that. How can you like actually do the math and copy down the notes at the same time? It's pretty but that's good. Yeah. So that means that this is 77.68. Thank you. And I'm gonna here tell you that you should have probably caught it. I should have probably caught it if I looked, because 75 should have the longer side across from it, the longest, right? And so, right, technically you should be able to catch it without even doing the math, right? Without even redoing it, I should have been able to catch it. But I'm trying to rush to make sure you don't fall asleep on me here. Thank you. We fixed it. So, I know this is going to be somewhat challenging. I'm not going to deny that. I will ask you sorry, I'm just making sure. You're not ready for a lot of them yet. But I would say 39 and 40, give it an honest chance. Give it an honest chance. So I'm going to say page 39 to 40. Let the diagrams that I've given you before, pay attention to this. Let the diagrams I gave you before inspire you to kind of see like which one would this fit under? Like which scenario am I looking at here? If it's angle depression, it's probably one of these here, most likely. At the very least, guys, if you could sketch it, interpret it, and put letters to it, that's all I would want you to do. If you can't solve it, if you're going to be like, nah, I'll wait for Mr. Dirksen to do it, I'll be okay. I prefer you solving it, but interpreting it is the hardest part. Thank you, guys. That's it for today.